Hello, everyone. Welcome to the BRAG meeting today. The mission of the mission of Berkeley Research Administration Group, BRAG, is to provide a forum for collegiate interaction in the research administration community. We do this by facilitating presentations by subject matter experts, creating an environment to foster peer-to-peer exchange, and seeking and sharing best practices. Today, we will hear from Professor Sarah Stanley on her research in tuberculosis. This will be a time for Q&A at the end of the presentation. Please add your questions to the chat as they come up, and we will get to them at the end. If you would like your question to be anonymous, please send it via private message to Sarah or me. I will now turn it over to Sanchita to introduce today's speaker.
I forgot to unmute myself as usual. Thank you, Sonia. Dr. Sarah Stanley received her BS in chemistry from Trinity University and her PhD in biomedical sciences from UCSF, where she was a graduate student in Jeff Cox's lab. Sarah also was a Helen Hay Whitney postdoctoral fellow at the Broad Institute of Harvard and MIT in Deborah Hung's laboratory. During her career, she has received honors and awards from the National Natural Science Foundation of China Fellowship for International Young Scientists, the Searle Scholar Award, the Hellman Fellows Fund Award, and the King's Sisi and Robert Womack Endowed Chair in Medical Research and Public Health. Sarah's research group studies innate and adaptive immune responses to the bacterial pathogen commonly known as tuberculosis. Today, we will hear from Sarah about the research being done in her lab to understand why natural immunity is not more effective against TB, what types of immune responses have the potential to be protective, and how her lab can use this knowledge to design new vaccines and immune-modifying therapeutics. So with that, I'll welcome Sarah Stanley to take over the stage. Sarah, the floor is all yours.
Thank you, Sanchita, and thank you, Sonia, and thank you, everyone, for coming. This is really exciting opportunity for me to get to talk about my research with many of you who I have worked with here at Cal over the years. So my lab works on TB or tuberculosis, and I want to start by, well, first a couple things. One is I'm really happy to take questions during my talk. And if you want to just unmute and ask, or if you want to put them in the chat, that's totally fine. I'll try to keep an eye on the chat. But before I begin, I want to ask something that I always start a talk to kind of people who I think may be new to hearing about TB from the scientific perspective, by asking the audience a little bit about what they know about TB. And one thing that I always do with incoming first-year MCB graduate students is when we give our first-year talk, I ask if anyone has any idea how many people die from TB every year. Any ideas? Okay, good. I'm seeing 1 million. Good guess, Kate. That's close. So it's almost 2 million people every year. And I will get into a little bit about the public health of TB in the first part of my talk. So what I'm going to do today is I'm going to give you kind of a long and extended background on tuberculosis and why I think it's important and what I think the important questions are in the field. And then I'm going to tell one story from my lab that kind of illustrates the type of work that my lab does and that is unpublished. So let me start by sharing my screen. Okay, and I definitely encourage people, if you have questions, put them in the chat. and I can stop and take them throughout, because I definitely learned during Zoom teaching that it's more fun for me, and I don't know, maybe for the audience, if people can ask their questions throughout the talk. Okay, so I think that I'm starting with this slide that talks a little bit about tuberculosis in history, because I think that for most of us who come from wealthy countries, this is how we really think of TB, as a disease of the past. So we know that TB has been around in humans for many, many thousands of years. There is this whole entire field of research where people try to understand how mummies succumbed to disease and died. And one of the things that they find is that often many of these Egyptian mummies and some of the mummies from Peru as well, the individuals actually died from TB. So this is an example of a priest from ancient Egypt who has the characteristic signs of tuberculosis when it invades the spine. We also know that TB was recognized as a clinical disease for a couple of thousands of years. Hippocrates was actually the first person to provide a clinical description of TB. And the way that Hippocrates described TB is very consistent with the disease that we're more familiar with today, except maybe their diagnostics. If you read this quote from Hippocrates, you can see the way that they diagnosed disease is a little not as advanced as what we do today. But by the 18th century, when people were really moving into cities and living in crowded housing, that's when tuberculosis became really epidemic. And around the time of the Industrial Revolution in the 18th century, it was estimated that 1 in 4 of all deaths in Europe and the United States were due to tuberculosis. And it was a very feared disease. It was called consumption. And so those of you who are interested in, in literature or in opera from the 18th and 19th centuries are probably familiar with the disease consumption. It's characterized by coughing. Eventually, there's enough destruction of the lung tissue that there's also hemorrhaging. And so there's this characteristic idea of a person sort of coughing into their handkerchief, and if they see blood, then it's sort of a sign that they have tuberculosis. And back then, there was not much that could be done, and that person was very likely to die from the disease. So in the United States, this is a chart that's looking at the major causes of death in the United States, comparing the year 1900 and the year 2010. And what you can see here on the left is that in 1900, the top 10 causes of disease, many of them were infections. So here we have diphtheria, we have gastrointestinal infections, we have tuberculosis, and we have pneumonia or influenza. So TB was in the United States, even as recently as 1900, one of the major causes of death. Now, of course, the picture has really changed in the United States, and in 2010, very few of the top 10 causes of disease were infectious in nature. And in fact, really only pneumonia or influenza here was in the top 10. And I think that when I used to teach infectious diseases prior to the COVID-19 pandemic, I was really, I really found that a lot of people didn't really have a sense that infectious disease was something that we need to worry about anymore, that it's a problem that's been solved. And I think this kind of changing landscape of public health in the United States and in other wealthy countries is really the reason people feel that way. Of course, I think the COVID-19 pandemic really changed the way people think about infectious diseases. And and it's been, I think, a really amazing opportunity for those of us who work on infectious disease to be able to take some of the concepts that the general public learned about from COVID-19 and then help people kind of think about those concepts in the context of other diseases. And so I was asked today to speak about my work on COVID-19, but I've actually quit working on COVID-19 because the whole world is working on COVID-19, and also COVID-19 is on the wane. I'm happy to answer questions about COVID-19 at the end. But today I really want to focus on tuberculosis, the disease that I study, because I think that it has an even bigger impact on global public health than COVID-19. And I'll tell you just a little bit about why.
Can I ask a
Okay.
question?
Yeah, go ahead.
In the slide before, when you guys report these different things like in 1900 and then in 2010, so for example, like cancer, right?
Mhm.
Well, I'm sure cancer research has gotten better, or cures or treatments have gotten better